Hello everyone, I'm Felicia Winter from TTS, and I'm talking about results from an interpretation study that I didn't do myself, so that's why Roberta Massotti is on that talk too. And I want to introduce you to Somaliland. And first of all, I want to go through where are we exactly on the globe. Then why re-entering Somaliland, what's interesting. The structural framework, building blocks of the petroleum system, what does that actually mean for the offshore prospectivity? And then we draw some conclusions for the onshore based on aeromagnetics. So where are we? Somaliland is at the Gulf of Aden, so that's conjugate to Yemen. And please observe the very oblique transform faults. The opening was oblique, the early rifting was oblique, and we are down here. That's the data set I will be talking about. This is an onshore geological map, and you can see that there are two areas very close to the coast that are structurally a bit more complex than the rest of the onshore, and these are related to also offshore basins, which you can see here on a gravity offshore. We do have basinal structures. And why re-enter Somaliland? The exploration started in 1910 with oil seep in Daga Shabelle, and in the 50s, a lot of wells were drilled. And they did actually find oil shows in the same area where the oil seeps have been found, but also a bit further north, towards the coast. And then in the 80s, even more shows have been found, and this time it was oil and gas. We are now having wells offshore with oil and gas finds, and we are further going into the onshore, where we have the Nogal, which is an older rift basin than actually where we are at the coast. At this time also the seismic was shot, and it was very speculative at the time. And the newest well actually drilled in 2012, again showed oil and gas, this time from Cretaceous, Jurassic and Triassic layers. So dry wells, why were they dry? It is believed that that's mainly due to the poorly defined traps, and either the seal or the reservoir themselves were very thin. And this means for us at the moment, the area is still underexplored, especially the eastern area and the offshore can still do with a lot more, because the exploration place seems to be there and they still need to be tested. So quickly to show you how that relates to offshore Yemen, because as some of us probably know, Yemen is producing. And this is a reconstruction from 2016. This is how it fits together with the oil fields offshore Yemen, which one of the fields is supposedly from Eocene carbonates sourcing the oil, and that is where the basin would be nowadays. That is the conjugate, very oblique. And the other basin where we don't have fields at the moment is where we found our oil shows, but the basin offshore and conjugate to the oil fields in Yemen is actually where the offshore wells have been drilled and show oil and gas. So, why Somaliland? It is the conjugate to Yemen, and Yemen is producing. We also have evidence for hydrocarbons onshore and offshore Somaliland. There are oil seeps onshore, as I just showed you. We do have shows in wells onshore and offshore. And the coastal basin structure that relates to Yemen is actually visible on seismic and also onshore and other data. What we found with our data, in addition to that, is that the structural traps are there throughout Jurassic, Cretaceous, and Tertiary times. So they are actually in place for the maturation and the migration of the hydrocarbons. So it's just a question of piecing it together correctly and to target it more confidently. And just a quick show into new government wants to kickstart the exploration offshore. And we do seem to have seismic acquisition at the moment offshore, I believe. And Ruckus and BP are planning seismic acquisition in blocks 9 and 12. This is stand from late last year, early this year, so if anybody has any updates on that, we are glad to hear about it. And there is also drilling planned for next year by Genel in the western Genel blocks, which is that area. So the structural framework. I base this on data we have that's onshore aeromagnetics and offshore seismic. Our offshore seismic is more than 5,000 kilometers in 2D, which is tying one well, the Bandar Harshau. And our onshore data is aeromagnetic data, and you can already see on that data that we have deeper structures which might be related to basins, and you have a lot of small-scale structures further onshore. And our data, the underlying data, has a line spacing of 25 kilometers, and that would already give us basement structures to 5 kilometers at least, so we can resolve the basinal structures. And the new infill survey here has 2.5 kilometers, which makes it actually possible to resolve small-scale structures of less than 1.5 kilometers on the onshore. A quick overview of the structures we're looking at. This area is generally referred to as the Gobian-Graben area, which I showed you earlier, if you remember, as the conjugate to Jeman's basin further in the east. We can see on the high-pass filtered to 100 kilometers cut-off magnetics that there are substructures like the Western Bavaria Basin in here, and the Duban Basin structures in here. Daban, sorry for that. What you can also see is that there are sub-basins and highs, which are northwest to southeast trend in here. We have the central plateau with a lot of small-scale features, so we are assuming we are in a basement structure here. And then we have even further south, we have basinal structures again with a different trend, and suggested rift arms are outlined. So what does that mean for the petroleum system? What building blocks do we have? Throughout Somaliland, onshore and offshore, we have Jurassic source rocks and Cretaceous source rocks. We do also have a tertiary petroleum system with Eocene and Miocene rocks, which have been actually, this is an onshore well, and the Bandar Harshau well is also on offshore, sorry, not onshore, is not depicted here at the moment. We then have reservoirs in the Mesozoic petroleum system throughout Jurassic to Miocene. We find sands, we find relatively good reservoir sands. The Cretaceous has a lot of, the Chizoma group is Nubian sands, refers to the Nubian Formation. And in the tertiary petroleum system, we have the Bandar Harshau group, which shows clastic and carbonates as reservoir, which were also drilled offshore and onshore. And then we have seal. We have a regional seal. The Eocene Talé anhydrites are believed to be a regional seal present everywhere. And we have throughout all the sequences actually, again and again, interbedded shales and mudstones that seal the current reservoirs. Let's go to the traps. Where are the traps? How do they look like? We have structural traps, tilted fault blocks from the rifting, and associated drag faults. We have flower structures, as you can see here very nicely. That is further to the west, we have that structure. And we do have the classic Horst and Graben systems from the rifting. We also have stratigraphic traps. They are mostly in the Neogene. That is due to the synrift infills and the infill of the Graben systems. We can see onlapping here. We also see contorites. General systems, they are a bit shallow. And the combination traps are also interesting. I can show you one later, because we do have a transpressional and transtensional system between the west and the east. We have a lot of very interesting structures here. There is a quick sum up of the petroleum system and the building blocks as we currently believe it could be. We do have a lot of reservoir in the late Cretaceous, early Paleocene, and again in the late, that's the synrift stage. We do have trap formations, as I said already, throughout the Mesozoic and the Tertiary, and we tested, offshore and onshore have been drilled, but we also tested with pseudowells and other locations offshore how it would work, and we tested Jurassic, Cretaceous, and Eocene source rocks. And our conclusion was that the Cretaceous, late Cretaceous source rocks actually are expelling with the data we have throughout the early Paleocene, and the Jurassic is still expelling into the Miocene. So the Eocene source rock is the one that is expelling latest, and that makes that our critical moment where everything comes together is the late Miocene in that area. So talking about the offshore, that would bring our play summary together that we do have the transform faults from the oceanic spreading. You can see here, we have a graben in the central bit of our data system. There is another transform fault here where the well is just about tied by our seismic. We do have Cretaceous rotated fault blocks, mostly in water depths 500 to 750 kilometers. We find pull-apart tertiary basins and Cretaceous Eocene horsts and grabens directly next to our transform faults in the east. But we also have, as I mentioned earlier, the transpressive and transtensional structures in the middle. We can later see a lot of N-echelon basins here, and they are in very shallow to 700 meter water depth. The Neogene stratigraphic plays I showed earlier are in that area, so that they are associated with the transpressive system too. Seismic examples, the western area, this is one of the lines where you can see tilted fault blocks, that's roughly where the Cretaceous is. The question always is, where exactly does the oceanic crust start on the shelf? And for that, we modeled a line, which you can see here, which is parallel to that seismic. And we modeled that whole thing with continental crust and synrift infill and pre-rift blocks. So it is possible, that's not proof that we have continental crust here, but it is absolutely feasible with the gravity and magnetic we have, that we are still on continental crust, transitional continental crust offshore, mostly where our data set is. So we are going to touch oceanic crust outside. That is another example from the western area. Again, you see fault blocks, rotated fault blocks in the Cretaceous. That's near-top Cretaceous. And we seem to have the infill and growth sequences with fault trends in the other direction at the mid-Miocene level here. There is a very nice structure that is associated with the transpressional system. We do have an anticline directly connected to one of the transform faults. And here again, we even have a structure in the central part of our data set where you can see basin slope fans, which show up on the AVO analysis actually as brights when I go back and forth. So this is promising, interesting data sets. Another very nice growth sequence is what we have in the east. That is a line not far off from the well. Bandar Hashau actually is 4 kilometers off this line, and that is our sequences in the Oligocene, Miocene, synrift, and the pre-rift structural high underneath. So can we draw some conclusions for onshore from our data? We have no seismic onshore, but we have aeromagnetics onshore. That is the data set. This is the interpreted data set. This is the magnetics unfiltered again. This is the interpretation on top of it. So what you can see, offshore you can actually see a gradient, horizontal gradient of the magnetics. And you see the N-echelon structures here, the nicely pull apart polygons. These are the transform faults from the spreading. And since we have the Nobel rifting over here, we have fault trends in a totally different, almost 90-degree direction. And that makes the entire area over here very interesting structurally. So that's just for orientation where we are. And now let's look at the domains we see onshore. We have 3 different domains we found onshore that are of complexity, of interest to us. Domain number 1 over here in the northwest is characterized by high amplitude and high frequency pattern in the aeromagnetics. And mostly you can see west-east trending features inside. So what does it mean? We think that might be related to the Miocene volcanism we can just about see in Somaliland, which is more pronounced in Djibouti. And that means in the aeromagnetics, you will mostly see the small-scale features of high frequency and amplitude. That is the volcanism on top of anything that might be a basin structure. But in other filtered data, when we filtered out longer wavelengths and something, you can also see here that there are underlying longer regional wavelengths that might be the rift-related basins. When we go to the second domain of interest over here, you see the pattern is totally different. We have a relatively low amplitude here and low frequency pattern, and also they are much more continuous, as we've seen over here. What could that be? So we found that the nicely connected features are in that polygon and that polygon. And when we look into the western polygon, we've actually found online data. And that seems to be a half-graben system here. This is an interpretation from 2016. And we again have the Oligocene, Miocene up here. The bright green is currently suggested to be the evaporite seal. And we have the Cretaceous infill here, and that's just about the Jurassic was drilled by that well here. So if that's a half-graben system that connects to that kind, you see the low is the half-graben and the high is that high. If that's what we see in the western polygon, then we don't have any seismic, we didn't find any seismic in the eastern area, but we have seismic offshore, and that's, again, our rift system and our rift basins we would see just offshore from our data set. So we thought if that's in a similar direction as the rifting was actually happening, does our model maybe look like this? So that is the onshore line you see here, and that is the offshore rifting, which we would see here, would expect over here, where the red line is. So is that just a continuation of what we see here? Is that actually looking like that? And we think that's a feasible argument in that area. And just because we're here already, that's again the interpretation on a straight line to the well we have tied. Then the third domain that's structurally complex onshore is in the south. You can see variable amplitude here and high to medium frequencies, so it's structurally more complex than both of the other areas, at least on the magnetics. We see a west-eastern trend, or we can think we see a west-eastern trend. And that, we think, is actually connected to the Nogal Graben, which is just east of our survey, so it's actually in Puntland, not in Somaliland itself. We would expect the big Nogal Graben is the early Jurassic rifting onshore, just to the east of here, but that is a similar trend, and the basins could still be related to that Jurassic rifting. But as I said earlier already, we have a totally different fault direction, fault trend here from the transform faults at the opening, which is the Oligocene rifting to opening of the ocean. And that actually makes our entire area kind of a triple junction, don't quote me on that, which is a strike-slip fault system with several faults in that direction. And we have the transform fault coming in here, and the rift grabens are like that. You've seen the half graben in that direction. So that would give us, when you see that west to east trending basinal structure, that is displaced by actually a lot of strike slip faults. As you can see here, for example, you have everything is a bit displaced into one direction or another. And that means that we have intrabasinal fault related traps, or would be expecting it. And what I want you to note is just something interesting. We mentioned the Anatolon structures earlier, offshore, and the basin again is in a similar trend direction as these structures here. And you've seen the rollover anticline against the fault earlier. So it could be traps like that that are existent in that area. That is the full interpretation from prospectivity offshore implied to what could it be onshore. And I just sum up for you, where are we, why we enter Somaliland, structural framework, building blocks of the petroleum system, and offshore, onshore. The most important points and the most interesting points where we are on the conjugate of Yemen. We know they have producing fields there. Again, I can't emphasize enough, we do have the oil shows offshore and onshore. We do have gas shows in addition to the oil shows, offshore and onshore. Onshore is just outside our area, it's in Puntland again. Then we do have rift basin margins, so we are in a regime that's usually found to be very, very attractive for the traps are in place, the kitchens are in place, the migration paths are in place. And fourth, we have tested source rocks, offshore and onshore. Offshore was tested, we found Jurassic and Cretaceous shows, and the Eocene and Miocene was also found in that well. The petroleum system, as you remember, we tested modeling. The maturation seems to be in a timing so that the traps are in place. We could charge them at the right time. So it is all there, the building blocks are there. Then the prospectivity offshore has shown you basin slope fans that actually have brights, which we have found in here. The rollover anticline was also in here. We do have traps, structure flowers in the seismic. We've seen it. We have seen the seal in the seismic. We have seen faults don't penetrate, don't breach. And then the implications for onshore are also that the potential is actually promising when we can draw these conclusions from the offshore. So you've seen the half-carbon structures are there. We can maybe even transfer them further south into this area from the Jurassic rifting even. So it's all in place, and Somaliland is not a write-off. That's from my side.
Thanks, Felicia. Any questions? When do you think the next well, we will see the next well or two in the offshore? I guess it'll be. But
in the offshore, no. Earlier it was proposed next year onshore.
Oh, okay.
How much that is actually happening or not, I couldn't say. But yes, the problem is offshore is it's very untested, and you know that these two wells over here, they showed oil and gas, and we are like we do see on the seismic. These interesting structures are all over here, and generally people believed whatever is there in Somaliland, there was uplift, there are faults that might, whatever hydrocarbons were there, they might have gone anyways. Everything was breached, the seal is not there anymore, the faults were reached. And we actually on the seismic, at least offshore, we do see that's not the case. So of course you would need to test that for the coastal area, and you need to check that for onshore. But it's
so
still...
Two, Rack and Janelle are the companies involved?
Yeah, exactly.
Okay. Sorry, yeah, go ahead.
Yeah, I guess at this point it's pretty much speculation, but could you give us an insight to the extent or the magnitude of the volume of oil that is present here?
I wouldn't be the right person to ask about that. We didn't do any volumetrics because our well ties were, that's not significant enough for anything we saw in here. So we did rough AVO anomalies. We could see the brights, but it's very much speculation, as you say.
Right. So earlier you mentioned that there was some, wells that were drilled back in the 1950s, I believe.
Yeah.
Do you know if they've calculated any volume in place of oil at the time?
They do actually have. I don't know whether I have it on the earlier slide. I don't want to scroll through all the lights right now.
No problem.
But I can look it up for you later. I think they have. I wouldn't know a number right now.
Okay. All right, thank you. Anybody else? Yeah, please, one more.
Hey, Felicia. The fields you mentioned onshore Yemen, which are producing, sorry, offshore, which are producing. So in terms of your petroleum systems chart, they're Eocene carbonate reservoirs.
Yes,
that
they
right?
were
Yeah.
using
And-
carbonates and clastics.
And the source rock is the Jurassic source rock?
No, they
or is-
believe it to be late Cretaceous source rock. So that's the late Cretaceous source rock we actually modeled. So in Somaliland, with the data and depths and lithologies we have, it's
Okay.
expelling throughout where our traps were built.
So in your areas 5A, 5B on that map, that would be probably the strongest play to be looking for in Somaliland is
Yes, we
an
do.
equivalent of those Eocene carbonates.
They are here. It's sandier too, from what we know, than it is in Yemen. Here we actually have reservoirs that are even older. We have late Cretaceous reservoirs we would be expect. The Nubian sands are actually the main reservoir you would be looking for. And the producing oil fields are actually conjugate to that basin over here.
Oh, okay.
So, and we have a bit less seismic here, so that is the place you would go for the Eocene clastics, just as a first pass.
Thank you.
All right, one more. Oh, no. You need to run. Push your phone in.
Could you just tell us a bit more about the seismics that were done by previous sort of holders of the licenses in Somaliland? I know that a large number of the majors were being involved from the 70s and 80s up until the point of the Civil War. And have you seen that sort of seismic that was conducted by the likes of ConocoPhillips and so forth?
Do you mean onshore?
Onshore and offshore.
The seismic offshore here is our seismic, actually. We're just not having in that block because it was, I can't remember who had that block earlier. But onshore, I've only seen what's there in publications. We didn't have a data show. We didn't have any possibility to see anything onshore. So the half-gram structures are, of course, the images that are shared online, I guess, because it's the better images. But that's all we had.
All right, thanks very much.
Thank you very much.
Thank you.